All right, so we're going to take a look at a couple problems that utilize those ways that we've learned that we can prove that a given quadrilateral must be a parallelogram. So in this first example, it says, in order for DEFG to be a parallelogram, then what does the measure of angle D have to be, and what does the measure of angle E have to be? So the only thing that we're given in this picture is that angle F is 115. Now we know that in order for a shape to be a parallelogram, the opposite angles have to be congruent. So if angle F is 115, then angle D would also have to be 115 degrees. So that one's not too bad. Now what about angles E and G? Now there's kind of two ways that we could go about this. For one, we could look at, once we know that angle D has to be 115, we can think about how many degrees would be left to split between E and G, and we'd keep in mind that those would have to be equal to each other. Or we could think about the idea that when a shape is a parallelogram, its consecutive angles are always supplementary. And I'm going to go that route. I'm going to realize that E would have to add up to 180 with both angle F and with angle D. Now they're both 115, so really what I would have to say is I would know that the measure of angle E plus 115 needs to come out to equal 180. So if I just subtract 115 from 180, it tells me that the measure of angle E has to be 65 degrees. So the angle E has to be 65 degrees. Now the other way to do that, just to show you real quick, is I could say that, well, 115 plus 115 would give me 230. Now I know that if I take that 230 and I add the measure of angle E and the measure of angle G together, I should get 360. So that tells me that the measure of angle E and the measure of angle G added together would have to be 130 if I just subtract the 230 from the 360. But again, since these two angles have to be congruent, I can just take that 130, split it in half, and each one of these would be that amount, and 130 divided by 2 is 65. So we could have gotten our answer that way as well. In the second example here, it says in order for JKLM to be a parallelogram, then what's the length of JK have to be, and what does the length of JL have to be? Now this one's a little bit trickier. We know that in order for it to be a parallelogram, the opposite sides have to be congruent. So that would tell us that in this picture, the 3x minus 2, which is representing JK's length, would have to be equal to the x plus 6, which is LM's length. So let's set up an equation that says that. Let's set an equation up that says 3x minus 2 has to equal x plus 6. Now, if we use our algebra skills and solve this, we're going to end up with 2x minus 2 equals 6. Add 2 to both sides. 2x equals 8, and that would mean that x equals 4. Then we can take that x equals 4 and substitute it back in for the x right here, and that's going to tell us the length of JK. So JK equals 3 times 4 minus 2, which is 12 minus 2, which is going to give us 10. So the length of JK would have to be 10. Now for the second part of our question, we have to find the length of JL. It gives us the length of JA as 2x minus 1. We now know that the x equals 4, so let's just go ahead and really quick figure out what does that mean for the length of JA. It's going to be 2 times 4 minus 1, which is going to be 8 minus 1, so that's 7. So JA equals 7. We know that in order for it to be a parallelogram, the diagonals have to bisect each other. So if JA is 7, then AL would also need to be 7. And then that would make JL equal to 7 plus 7, which is 14.